where it makes turns and then return to your body. So let me pick up another diagram here which explains that. Okay, let us pick up this one right here. For this first. Okay, now this was the glomerulus that we saw, and this is the part that came out and it goes through all these loops and curves, and then it comes to a big one here. And this is where the urine will be passed to the renal pelvis. Then the renal pelvis, it comes in little microscopic drops. But these drops will make large drops, and then it will make a lot of urine. So then that passes through into the ureter, and then from the ureter it will go to the urinary bladder. When the urinary bladder is full, it will be released. So this is the pathway that it takes until it comes out of your body. But there are a lot of parts that you have to know. Now, like from here, this part is called proximal convoluted tubule. That's a long term that you have to make sure that you note it in your notes, because next test, which is midterm, you will see all these things in the test. So you have to remember it. You cannot remember it if you don't have it in your notes and review it. That's why you have to take notes. So this is called proximal convoluted tubule. There are three words combined into one term and one structure. This is the whole thing is called proximal convoluted tubule. Proximal convoluted tubule. Proximal convoluted tubule. If you repeat it so many times, you learn it like a song. So proximal means the first part. Convoluted means bends, curves, like loops. If you look at this, look at loops, curves, like waves. That is convolution. Then tubule, because it's a tube. So proximal convoluted tube is the tube which has loops and which is the first one. The first one to come out of the capsule, the pockets. So then it starts to form a straight path which makes another U-turn here, another big loop, and then it descends here and then it ascends here. It comes down, it goes up, and then it starts making loops again and it joins this one. So this part here, this loop is called loop of nephron. Sometimes they used to call it loop of Henle, probably by the person who first noted, studied this and discovered it and put it into the records in the literature, scientific. So this is the loop of the nephron or loop of Henle. So it comes up here. So this part is called the descending limb. It is not labeled there, but I want you to note it because in other books you will find it labeled descending limb, because it's like a limb, like you have your lower limbs and upper limbs. So this is the descending that comes down, and then the part that climbs up is called the ascending limb. So you have the descending limb and ascending limb. Then it begins to form curves again. So here it is given a different name, which is almost similar to this but different. This is called distal convoluted tubule. Convoluted tubule is still the same, except this is distal. Now, in scientific terms, we have two contrasting terms. Proximal means upper, distal means lower. So proximal means the beginning and distal the end. So you see, it started making curves here, that's why we call it proximal. But then it starts making curves here, which is the last part, which is lower, so this is called the distal. It's the opposite of proximal. Distal convoluted tubule. So at the distal convoluted tubule, it will join into a bigger, so like tributary of a river and forming with another tributary and forms a big river. So this is called a duct, collecting duct. You have to know those labels. And tomorrow in the lab, you should be able to draw them and label them out of your memory. That's when you have learned it. If you cannot draw it and label it, you have not learned it. And that's why you come here. You come to learn it. So this is the collecting duct. A duct is also another word for tube, but it's a bigger tube. Look at the size. This is bigger than the other ones. So collecting, because it collects many of them together to make it into a big river. Like many small tributaries of a river, they make a big river. So this is the collecting duct. Now, collecting duct will now take the urine to the pelvis, the renal pelvis, which we saw earlier in the big picture of the kidney. So from the pelvis, it's like a funnel. Like, you see, you know what a funnel is? Like a triangular thing that you put into your, if you're adding oil into your engine, it looks like a triangle with a tip, and then it can channel all the oil into your engine. So the renal pelvis is like that. Look at the triangles. This is like a triangle. So the pelvis is here, and that will collect all the urine from the entire kidney, and then channel them into the urethra. And the urethra is the tube that will take the urine to the urinary bladder for storage. And that's the end of the story. So, finally, we talked about three processes in the formation of urine. We have talked about the first one, which is filtration, which occurs here, the glomerulus. The second process is secretion. To secrete means to throw out. So there are some molecules which are secreted. They don't go through this. They come here, but then they leave the tube and they're secreted back to the mainstream, the artery here. So it means they are taken back to the body directly from the tube in the kidney. So that process is secretion, throwing it out. So they don't reach here, they don't come here. So they go back to your body. Because some of these, they are needed by the body. For example, molecules like water. Now, kidney is functioning like a control. It does not want to take too much water out of your body. If the body sees that, no, you're taking enough, I'm going down, my level is going down, then it tells the kidney to send more back. So the one that goes back is going through secretion back to the body. So the absorption or reabsorption, that is the other process. To absorb means to take in. Reabsorb means something which has been thrown but is now taken back. So there is a reabsorption also of water and some other electrolytes along the tube, this tube here. Some of it, you look at this molecule of water, look at the arrow, it is going out. It came into this tube, but now it's going out. The same thing here, it escaped until almost the end, the terminal for the destination, but it is going back. Why? The reason why it is going back, because the body senses, like a sensor. The body feels that, no, I'm losing too much water, so bring some more back. So some of this excess water will be taken back to the body to keep the normal level of water in the body. Because water has to be kept at a constant level in your body. If it is too much, it will be thrown the excess out. If it is too less, it will reserve, put more back, and also ask you, force you to drink more water to keep the level. That's why you feel thirsty. So, we have now seen all the three processes in the formation of urine. We have seen the first one, which is what? The filtration. The second one is secretion, and the third one is reabsorption. And that almost completes our lecture for today for the urinary system. Any questions? Okay. Now, there is something more that I kind of skipped, which is very important here when we talk about the organs of the urinary system. let me go back because this is very important and I don't want you to miss that without mentioning it. I don't see, although the diagrams here, I don't see the one that has it. Like you can see in most of the structure for the urinary system. And I don't know why they skip that, but maybe. Okay, look at the one in the textbook. Oh, you don't have a textbook. Okay, I'll show you. You can even Google it, pull it out from one of the images, and you see a triangular organ on top of the kidney. I want to pull up a better image that will show you that one. I want you to see it because you can see it more in the lab. It's already almost 3. Okay, this is the adrenal gland. Adrenal gland in most of the textbooks of the pages, every time when we discuss the kidney, you find it on top of the kidney. So this is the bean sheet that you saw that it is right here on both kidneys, like a triangle on top, the yellow one. So adrenal gland actually is not part of the urinary system. It's not, but it has a role in the urinary system, but it is basically an endocrine system organ. So it belongs to the endocrine system. Now, the endocrine system is the system of glands all over the body. These glands produce secretions called hormones. But adrenal gland is connected to the kidney. It is attached to the kidney. On top, at the tip, on top of each kidney, is a triangle. Adrenal gland. So adrenal gland also plays a role in urine. So it plays part in both systems. Mainly in endocrine system, but also in urine. Because it also contributes to the concentration of urine. Because urine can be dilute or concentrated. When urine is concentrated, it has a yellow color. It's dark. Sometimes you see that it is very dark yellow. But if it is diluted, it's almost almost pure water. So adrenal gland produces a hormone called aldosterone. And aldosterone will absorb sodium. And sodium, whenever sodium is absorbed, water is also absorbed. Because sodium likes water and water likes sodium. They're like friends. So wherever they go, they want to go there. So when sodium is absorbed from the body, back to the blood, water will also be absorbed. So that way, it will move water from the kidney back to your body. Then if water is taken away, it will be more concentrated. And if it takes too much water into the body, then sodium always takes part in the circulatory system, the blood system. So your blood pressure can go up with sodium. Now look, sodium can form crystals called sodium chloride, which is the common salt that you put in the food, sodium chloride, NaCl. And sodium chloride increases blood pressure because it absorbs more water. When you have more water in your system, your blood pressure will go up. That's why those people with high blood pressure are told by the doctor not to put too much salt into their food because it will worsen their condition because their blood pressure is very higher than normal. So that is one of the organs that always included with the organs of the urinary system. That completes our lecture for today. So let us review very which? What is the most important function of the urinary system? Pardon? Removes the wastes. And which are the wastes? Water, excess water, what else? Urea, what else? Ammonia, what else? Uric acid.
Already fixed this.
Pardon?
Already fixed it. We're gonna make the grid.
Which step?
The quiz. Tell me the quiz.
What do you mean you're ready?
Already fixed quiz.
I'm not giving the quiz. Huh? I was giving the lecture. What do you mean that you were giving the
You
quiz?
said we have a quiz to the quiz.
Yeah.
We're already fixed.
When did you take it? When
They're
did you
ready
take
to
it?
take it.
I said we're
We're ready to
take
take it.
We're ready.
Oh, you're ready?
Yeah, we don't need a
Oh,
review.
man. The way you speak, I'm not ready. You said, I thought you said you are ready.
Ready.
All right, okay. Okay, take out a sheet of paper and write numbers 1 to 10. Where's the signing sheet?
I always keep it on the table.
Huh?
So I always keep it on that table.
Okay, here it is. I got it.
Yeah.
Okay, so write your name, today's date,